Let's talk about one of the internet's greatest secrets, something that feels like pure magic. How does a massive movie file travel across the entire world and land on your screen in, like, seconds? Well, it's not magic, but it is based on one brilliant and incredibly simple idea.
I mean, really think about it. You click play, and almost instantly, a huge, high definition movie starts streaming. We take it for granted. But how does the internet actually pull that off without just grinding to a total halt?
All right, to wrap our heads around this, let's use a simple analogy. Imagine you have to mail a 1,000-page book to a friend. Your first thought might be, okay, I'll just find one gigantic box and ship the whole thing at once. But, as you can probably guess, that would create some serious problems. First off, that box would be a total nightmare to handle. Heavy, awkward, a real pain for every single person in the postal system. And worse, what if that one single box gets lost or damaged? Well, the entire book is just gone. Poof. Forever. And finally, a package that huge would create a massive traffic jam, clogging up the whole system for everyone else. This is the exact problem the internet's pioneers were up against.
So, what's the smarter way to do it? Well, instead of that one giant box, what if you sent the book one page at a time, in thousands of little envelopes? This, right here, was the aha moment that made our modern internet possible. The solution has a name. It's called a packet.
This really gets to the heart of it. That one big box method is clumsy and super risky, but the internet takes the smart approach. It breaks that huge file into thousands of tiny envelopes. It's just way more efficient, way more reliable, and a much stronger system.
So, what exactly is a packet? You can just think of it as a small, bite-sized chunk of a larger file. Seriously, everything you do online, sending an email, loading a web page, or even watching this right now, it's all happening because big files are being chopped up into these tiny digital envelopes to make the trip.
Okay, but for this whole system to work, these digital envelopes need instructions, right? I mean, how do they know where they're going? And how does the computer on the other end know how to put them all back together in the right order? Well, to figure that out, we've got to look inside.
Every single packet has two basic parts. The first part is the payload. That's the good stuff. A tiny piece of the movie, a little chunk of a picture, a few words from your email. That's the letter inside the envelope. But the second part, the header, that's where the real magic happens. The header is all the information written on the outside of the envelope. The header contains all the critical info. It's got the destination and source IP addresses, which are basically the to and from addresses. But the absolute game changer here is the sequence number. If your movie gets broken into, say, 5,000 packets, this number tells the receiving computer, hey, I'm packet 1 of 5,000, or I'm packet 2 of 5,000, and so on. It's like a page number for the internet. All right, now that we know what a packet is and what's inside, let's actually follow one on its incredible journey across the digital superhighways of the internet. And all of this happens faster than you can blink. First, your device splits the file and addresses each little packet with a header. Then they're sent out into the wild. From there, special devices called routers act like little digital postal workers, reading the address and routing each packet along the best path. Once they arrive, the destination computer uses those all-important sequence numbers to reassemble them in the correct order. And get this, the final step is verification. If packet number 250 is missing, no big deal. The computer just says, hey, can you resend packet 250? It only needs that one tiny piece again, not the whole movie. Now, this is where it gets really cool and shows you why the internet is so powerful. The packets don't even have to travel together. To get from New York to Tokyo, one packet might zip through London and Germany, while another one might go through Los Angeles and Hawaii. The network is constantly calculating the fastest, least crowded path for every single packet. So you might be wondering, wow, that sounds complicated. Why go through all this trouble? Why this complex dance of splitting files up just to put them back together? Well, the payoff is the incredibly fast and reliable internet we all depend on every single day. This system gives us 3 massive advantages. First, it's super efficient. Because the pieces are so small, no single user can clog up the whole network. Second, it's incredibly resilient. Losing one tiny packet out of thousands is no big deal. It's easily resent. And third, it's unbelievably flexible. If there's a problem in one part of the world, like a cut cable, packets are just instantly rerouted around it. So I'll leave you with this. The next time you see that annoying little buffering icon spinning on your screen, you'll know exactly what's going on. Your computer is literally just waiting for a few missing packets, a few of those digital envelopes, to arrive so it can continue the show. It's not a glitch, it's the system working exactly the way it was designed to. Pretty cool, right?